Hello, everyone, and welcome to the September 2014 Professor Messer Live Network Plus Study Group. For those of you that weren't in the pre-show or you're watching this on the replay, you've missed me scrambling around. I was 20 minutes prior to the study group changing out SDI cables, which are the video cables that I use around here, because I wasn't getting one of the video inputs on my video switcher, so you wouldn't be able to see the presentation. So obviously this was a bit of an issue. I had some backups, of course, but one of the challenges with doing some of these things is that you're now it's 30 minutes before the study group. You're busy changing things around, which really you don't want to be in a position of doing. And if I had to do it over again, I probably wouldn't. Ultimately, I fixed the problem by rebooting the video switcher. After all of that, I tested cables, I tested video converters from HDMI to SDI, I swapped out the video converter, I moved some around, I changed out cables. That was fantastic. So one of the things that I like to do in these study groups every month is take you through all of the questions that you ask of me. This is something we just like to do every month. And our latest version of this study group is one where it's more of a pop quiz. I set up some questions and we answer them. And I'll tell you in a moment how we make that happen. But I want to thank those of you that continue to support what we're doing here, building out these particular these training courses, putting them online for absolutely free. I do offer these training courses in an offline version as well. You can go to professormesser.com/download-network plus to learn more about that. And of course, if you'd like to see what we're doing all the time, you can follow me on Twitter. You can follow me on YouTube. You can follow me on Google+. Just type professormesser.com/ and the service that you really like. YouTube, Facebook, Google+, and it will find me there somewhere. If you are watching this live, I've got a chat room here that is I'm also watching. This is not the YouTube chat or the YouTube comments. You'll see if you're watching this on the YouTube side, there's nowhere to put comments on this video. That's because I have one chat room. It's on professormesser.com on every single page of the website right there at the bottom. And as things go through here, you can absolutely send me comments, ask questions about the questions or the answers. And in the last half of the show, I take your phone calls. So the phone number is also on professormesser.com/live to be able to do that. Well, before we get any further with this, I was setting up and doing this presentation and getting it ready to go and creating the questions, because I build the questions myself every week so that we're able to go through all of these. But I flipped over to the YouTube side to set up this YouTube live session, and YouTube told me that I have now 20 million videos viewed. We hit this milestone of 20 million on YouTube. Now, technically speaking, I had 1 million views on other services before coming to YouTube, so we're really at 21 million. But this is more like the turn of the century millennium question, isn't it? YouTube says 20. It's a nice round number, and I'm going to put my stake in the ground and say that's fantastic. And I wanted to extend my thanks to you for watching these videos, for sending me the emails and the words of encouragement, for telling me that you were able to pass your certification. It really helps keep things going here. It's very, very motivating. And one of the things that's just a byproduct of that is we happen to have 20 million views on YouTube. So I want to thank all of you for that. And it's something that I was very happy to see when that came up. I really feel like we've got some really good things that we're doing for the IT industry. So fantastic to be able to see that. Now, I mentioned today that you'll be able to participate. It's not just videos viewed. We get to have these live events and you get to participate. So if you want to go to Socrative.com and you want to just in your browser go to the student login and put any name in. You don't have to put your name, but it's going to ask you for a room name of your teacher, and that will be me. Just put Professor Messer, all one word, and you'll be able to follow around in the rooms that we have here, and you'll be able to see. If I pop this up, you'll be able to have a view like this where you'll be able to answer these types of things. Now, we also have apps that you can load on your iOS, your Android, or your Windows mobile device. So you can run all of this from your mobile device. You can watch your stream on your computer. You can follow along with the Q&A on your mobile device, however you'd like to do it. That's very, very easy to be able to have those and be able to So follow along because I'm going to ask you questions. And if you're in there right now, you will see that I'm already asking you a question on Socrative.com. And this question is, how long have you been studying for your Network Plus certification? So there's where you'll be able to see this type of view. So I'm going to ask you, have you been studying for less than 3 months? Let's see if I can make this a little bigger so we can see it on the stream here. Less than 3 months, 3 to 6 months, 6 to 9 months, 9 months to a year, over a year, or perhaps you even already have your Network Plus certification and you're watching this to play along at home, see if you really remember the things from your Network Plus certification. And of course, it's good for CEUs, those continuing education units from CompTIA as well. You can get a few of those too, that and I'll mention later on in the stream how you can also get credit for watching this and get a CEU along the way if you're using CEUs to renew your Network Plus certification. There is quite a bit going on with Network Plus right now. For those of you that have been watching what we're doing at Messer Studios, we've been working on quite a bit of Security Plus. That's the latest certification that's come out. If we go and look at, though, if you go to Socrative and you have a look at what's there, I get to now see these answers. So 24 of you have answered. 46% have said less than 3 months, 13% 3 to 6 months, kind of the normal curve that we have here. It kind of curves down. And then I already have my Network Plus certification. 22% of you who are participating in that Socrative room already have your Network Plus. So I'll make sure I give you a way to send me an email and get certification for watching this later on with those pieces. Well, I mentioned there's a lot going on with the Network Plus certification, probably because it's been out since 2011. So if we do the math, we know that CompTIA tends to release new versions of their certifications about every 3 years. And although CompTIA has not said anything yet, I don't work for CompTIA. I don't have a relationship with CompTIA. I'm not a CompTIA authorized, whatever they are. But I do know that I did this in 2011 in December, and I do the math, and we're coming up on 3 years. So I fully expect that somewhere around the end of the year, beginning of next, we'll probably see a new version out. Now, if you're already studying for your Network Plus, that's okay, because they tend to give you another 4 to 6 months after that. This is what they've done in the past, is they have this overlap area where you can take both certifications. So if you're studying for the current cert, keep studying. You got plenty of time. You got 9 months of a ramp before you even have to worry about that exam going away. And whether you pass the old certification or the updated version of the certification, you get the exact same certification in the mail. You are Network Plus certified regardless of which one you take. So don't worry too much about that. There is quite a bit that we saw change on this version, dealing with OSI, dealing with virtual networking, security. I think we'll see more of that in the new one. We'll certainly see a lot more virtualization. Maybe they'll throw some SDN in there. I haven't seen the exact exam objective because they haven't released them yet. So I'll be looking forward to be able to do that. So that's something to think about as you're going through, and also think about how you're going to study. You've already gone through the videos, you've already read through your book, and you'd really like to take all the information from all of my videos, and you'd love to be able to take all of that and have it all in one place. And I've created for you exactly that. I have my CompTIA Network Plus study guide. I'm going to pop this up so you can see it. This is the PDF study guide that I have available. I've taken all of these charts and diagrams and information directly from my videos, and I put them into some course notes. It's effectively what this is. It doesn't replace your book. It doesn't replace the videos, but it's a great way to have everything in one place. How does DNS work? I put the exact diagram from my video right here. All of these details are in this Network Plus study guide. It's 11 pages long. It's got everything you would need in there, and I've made it available for $10. You buy it. It's a PDF file. It's not protected. You can put this on all of your devices. You won't run into restrictions trying to print it. If you'd love to print it out, go ahead, print it out. As long as you use it for your personal use, you can do whatever you would like to with it. I think that's the right way to use some of these products out here, and it's relatively inexpensive. You've got $10 to be able to do that, and every single penny of that goes back to running what we do and the Professor Messer, and primarily the Professor Messer website, which has some pretty extensive hosting costs these days, and this goes a very long way to taking care of all of those things. So far, it's something that has been allowed me to continue to do this and not worry so much about where the hosting costs are coming from, because you're effectively taking care of that. It's a nice way to do something like that. There is, you can find out more about that at the Professor Messer website, professormesser.com/netsg. Okay, enough of the precursing announcements that we are discussing. What I'd like to do is now let's ask some questions. This is the pop quiz portion of the live stream. In about an hour, we'll take some phone calls and I'll take questions from the chat room. But in the meantime, go to Socrative.com and you'll be able to connect to that and see this question. And I should probably go to the next question on my side so that you can also see that. Let's do that. Let's click the right thing on my screen, shall we? The question is, which of these attack types works by overwriting a section of memory that was not intended to be modified? Well, that's a very good question. So I've got a few options available for you to answer on this. And the options are, here we go. This is an attack type that overwrites a section of memory that was not intended to be modified. Is it an FTP bounce attack? Is it a buffer overflow? Is it a SQL injection? Is it a denial of service? Or is it a man in the middle? So I've started our Network Plus discussion in security. But as you know, security is a big part of the Network Plus certification exam. And there are certain attack types that you need to understand and you need to know how they work. And this is one of those. It's an attack type that overwrites a section of memory that was not intended to be modified. This is a relatively common attack type as well. I'll tell you more about that in a moment. But if you go to Socrative.com, to the Professor Messer page, you will be able to participate and answer that particular question. Which of these attack types? Is it FTP bounce attack, buffer overflow, SQL injection, denial of service, or is it man in the middle? And that's where we start to look and try to determine how are these attacks coming through. We want to be able to see this. And again, no answering in the chat room, please. We all want to have the same chance at getting this done. So this is when we really have to think about how these particular attacks are working. And we've got a number of people who have answered so far. So let's flip over and see what the results are. None of you have said FTP bounce attack. Good for you. It's a relatively old type of attack. You really don't see FTP bounce attack any longer because you see these other kinds of attacks, like 73% of you who have said buffer overflow. Well, that's probably a pretty good guess, but 24% of you said SQL injection. So we've got a little bit of a discussion going on there. None of you said denial of service. 3% of you said man in the middle. So which one of these would it be? This is one of those when you start getting into the questions and trying to figure out what is this kind of issue. If you're overwriting parts of memory, then most likely we're talking about a buffer overflow. Now, this is the way a buffer overflow works. You've got, in this particular example, a couple of variables that are in memory. You got a variable A and a variable B. They're right next to each other in memory. And if you looked at the value, neither of these variables right now, or A, the A variable has nothing associated with it, no value at all. The variable B has the number 1979 in decimal in that little section of memory. And if you looked at the memory and you looked at it in hexadecimal, it would look like 07BB. And you can see the hex value of A is all zeros because we have not assigned anything to that in our program. So in our program somewhere, the program is going to add or assign information into that section. But notice A is a certain size. You can't really change sizes there of this. We have allocated a certain amount of space for variable A. So what the bad guys will do is realize that they can manipulate this badly developed program to be able to put a lot of information into A, and what they do is put way too much. So they've put the word excessive, which is EXCESSIV, and notice it takes up, it overflows that particular buffered area for A and flows into B, so that E is actually, if you look at it in hexadecimal, is 65. So there's where you run into challenges. We just changed the value of B by putting in information in A, by overflowing the variable A. That's not supposed to happen. That should never happen. Now, we don't know what the result of that might be by overflowing it and adding that information to B. That's up to the bad guys to figure out. They'll try to find the right information to overflow into that variable to be able to, in the best possible case for them, to gain access to your computer. That's what they're trying to do. It seems like a very simple thing. And in fact, if an application's not not developed very well, this can be a very, very bad problem because it is so simple to take advantage of until they patch the app. That's why we get those monthly updates from Microsoft that says you need to patch these particular files that are in your operating system. That is why. So buffer overflow, for those of you that answered B, buffer overflow, you would have been absolutely correct. It's not an FTP bounce attack. We talked about that one. SQL injection doesn't actually change the memory. In fact, you'll look at the question here. It works by overwriting a section of memory that was not intended to be modified. With SQL injection, we're actually passing through a SQL command and getting a SQL response. That's not really overwriting memory. That's manipulating in many cases, a browser front end to gain access to a database. We're not really overwriting anything to gain access to that. We're simply sneaking around the user interface to be able to interact with the database directly. Certainly not denial of service and not man in the middle, because man in the middle is simply taking what you're doing, perhaps even modifying it, or perhaps not modifying it and sending it on its way again. We are definitely not doing that piece again. So very, very useful to be able to do that. It's up to the developers to write their software to not have this happen. They have to check and make sure that someone can't provide too much information into their program. They need to check the inputs and validate the inputs that are coming in to make sure they are a certain size, a certain type, a certain range. You know, if somebody is expecting in the United States zip codes, you don't expect someone to put letters and numbers in there. So the developer has to validate each one of those inputs. It's a very, very detailed way of going through and making sure your applications are secure. It takes a lot of work and it's easy to miss things. And that's where buffer overflows come from. Let's do another one, shall we? We're getting the hang of it. I see a few of you are trying to get into the room. Make sure you go to Socrative.com and go to the Professor Messer room. It's all Professor Messer. It's one particular word that you put in there. In fact, you can see the room number right at the top. The room is Professor Messer. Oh, I may have just caused a problem for myself to be able to do that. I have a program that I use to there we go, Professor Messer. I have a program that I use to put this information back and forth and be able to see the screen in a certain way. And I may have, we got it back. We recovered, everyone. It's okay. We're going to be all right. Let's do another question, shall we? I got a lot going on today. This is the best study group ever. Things are just falling apart. There's things on fire over in the corner. It's quite all right. We're doing just fine. Let's do another question. The question is, which of these would be commonly used with AAA authentication? AAA authentication. Now, this is not, this has nothing to do with the American Automobile Association. This must be something else. And you have some options available to you for these particular questions. The options available are, so you have to read this question, which of these would be commonly used with AAA authentication, pick two of these, and the answers, the possible answers are Radius, TACACS, IMAP, SSH, SMTP, and SNMP. So again, I like to have these multiple step questions where you have to first know what AAA authentication is. And then, of course, I give you a bunch of words here that are abbreviations of something, it seems. So what could these abbreviations possibly be? You'll be able to go to Socrative.com and be able to answer those in there. You can see in that view exactly what's going on there. There's a lot going on. We use this AAA functionality, this capability quite a bit. Even if you don't see it, this happens a lot behind the scenes, and we'll talk more about that in just a moment. You'll be able to see quite a bit with these authentications that we're working with. Let's have a look then. If I flip back here, let's see how we're doing so far with the answers. Which of these would be most commonly used with AAA? I think I can fit all of them on the screen here. I absolutely can. Here we go. So 46%, obviously we're getting quite a mix here. Radius, TACACS have gotten a number of percentages of answers. SSH, probably on the third with 14 or 15%. And a few of you have said IMAP. Some of you said SMTP, and some of you said SNMP. Remember, do not answer in the chat rooms. That would not be a nice thing to do. Whoops. There you go. Answer in the chat rooms. We got quite a bit to go through with these. There's a lot of words on the screen. So which one of these could this possibly be? We use AAA all the time. This is something that usually happens behind the scenes. You're logging in with your VPN. You're connecting through your Active Directory login. You're coming in through a web browser and you're authenticating to log into a router or switch to do administration. You're probably using some type of separate authentication mechanism. Now, the reason we do this is probably 3, 4, 5-fold if we think about it. The way that these, if let's say we're logging into a switch, the way this works is the switch is looking for a username and password. And it's very common to have a username and password embedded within the switch itself, to have this local database of names, usernames, and passwords. Well, that's great if you have one switch, but what if you have 20 switches? What if you have 100 switches? What if these switches are located anywhere in the world? You don't want to have to go to every single switch and add your administration there. And what if you have to change your password? Now you have to go to all 100 switches to change your password. That's ridiculous. Why would you want to do that? Instead, you tell the switch, if anybody's logging in, go to our authentication server to be able to determine who that happens to be. And this is an abbreviation for authentication, authorization, and accounting, or AAA. That's how we refer to it in the world of networking. Somebody will say, where's your AAA server? And you'll go, is that how? I don't know what is that a thing? Yes, that's your authentication, authorization, and accounting server. We never say it. We just say, where's your AAA server? That's where everything's going to be. So everything is centralized in one single database. So if you need to change a password, you go to that one single database, change the password, and now it's changed for all of the devices that use that authentication database. Very, very useful to have that there. So if you are doing something like logging in via a remote access, logging into your router or your switch and performing administration, you may be using Radius. That's one of those answers. It's one of those things that we discussed. One of the ones that was on that list was those pieces. Radius is certainly a good example of a AAA authentication mechanism. The AAA for Radius can really come in as these remote clients, these wireless clients. You can have people on your local network. They're trying to log into a server. That server is going to access that AAA server in the back to make sure that your username and password are correct. And it's using this Radius protocol to make that happen. The Radius protocol, very standardized. So that way you can bring up a remote access VPN device. You can install a router. You can install a switch, you can install an operating system, and you can simply tell all of those devices, please use Radius for authentication, and here's the IP address of the server that we're going to authenticate with. And all of those, it's a very standardized way can make that happen. Another way to do this is with TACACS. It's kind of cut out the word there, but it stands for Terminal Access Control, Access Control System. This is one that has been primarily Cisco-centric, but there are some standardizations around this. These days, almost everybody, though, if you're Cisco, you're probably using TACACS. Even the Cisco authentication server, though, can also enable Radius for those devices that don't know how to perform, for instance, TACACS plus authentications. So it seems odd that we'd have Radius to do some things, TACACS to do other things. There's also Kerberos. That's another common way to do authentication. We have so many different ways to do this. Each one of these has advantages and disadvantages about it. So that's why we have a mix. And in many environments, you might have more than one of these running at a time. You might use the Kerberos for your Windows authentication because that's what it uses by default. It may be doing an LDAP lookup to your Microsoft database from some products. It may be doing TACACS for your Cisco authentication. You may be using Radius for other third-party devices. Very, very, very useful to have that capability there and those things. So that's, you folks did pretty well, because if we look at the results, we can see the vast majority of you definitely said Radius and TACACS. That's one of those to be able to make that happen. So now let's try another question, shall we? I've got another one for you. Which IPsec mode encrypts your IP address and data during transport? This is a very sort of vague question, very quick question. IPsec, obviously, very comprehensive technology. So if I'm asking what IPsec mode encrypts your IP address and data, I must be referring to something very specific. And if we look at the possible answers here, we have encryption mode, we have tunnel mode, we have transport mode, we have authentication mode, and we have secure mode. IPsec is a big animal. Now, fortunately for Network Plus, we only have to know kind of the high-level view of IPsec. So you not only have to know what IPsec is. That's one important part of this question. We have to also know how IPsec works in its encryption and then the methods that it uses to encrypt this information. Again, no answering in the chat room. We're going to try to break this down and see which one of these could this possibly be. So now you have to think back to your IPsec piece and see if you can remember just which one of these things is doing what. This is, if you've ever set up IPsec before, just one of the things that you can configure inside of this, because you can configure IPsec to do a lot of different things. This is one of those that you'll run into quite a bit. Just go to the Socrative website or go to your app, and you should see the question right up there on the screen. Let's see how we're doing so far. One of the things I like to do with these questions and these answers is to kind of fool you, or at least get you thinking about IPsec and how it works. I don't think this one really fooled very many people, because 74% said tunnel mode, 5% said encryption mode. We are encrypting, so it would make sense that it would be encryption mode, wouldn't it? 9% said transport mode, 9% said authentication mode, and 4% said secure mode. Well, I made up most of those. Most of those don't even exist. They're fake words that I made up to have to do with IPsec. Now, IPsec is very broad to be able to do that. And you notice we're going through a lot with networking and with encryption, and that's a big part of the Network Plus certification. That's why I put this one in here. I think the rest of mine, I'm kind of getting away from security from this question on, but I think it certainly speaks to what we have to know for our Network Plus certification. If we look at this authentication modes, or the authentication header that IPsec uses, you'll notice that it can take the information that you have. You're sending everything in the green. You're sending IP header and data information. That's what's in the packet that you're sending between one place and the other. And what IPsec can do is it can put its own header in the front of this. For authentication, it puts its own header. It's not really encrypting very much in the authentication header. When you get into the ESP, or the encapsulation security payload, is where it starts encrypting the data that it puts inside of it. Notice it's putting everything inside of it. It's wrapping its own IP address around it, and it's putting all of your information in the middle. So it's encrypting both your IP address and the data and sticking it in the middle, and it's doing that in something called tunnel mode. Now, if we were not running tunnel mode, we were simply sending the data through, but using the original IP address on the very front of it where we're sending this information from, we call that transport mode. So those are the two modes that we are looking at, or we're talking about when we are doing this encryption with IPsec. If you're doing site-to-site encryption, where you have two firewalls, for instance, and those two firewalls are set up to encrypt everything that goes in and everything that comes out of it is decrypted, then that is generally a tunnel mode. That's exactly what we're doing. We're having the firewalls just take all the information, we're sending it, it wraps it up inside the tunnel and encrypts the data and sends it across. If you're doing something from the endpoint, you might even generally use transport mode to do that. So a client-based IPsec piece of software probably is using something like this data mode to be able to do that, this transportation to be able to do that. So if we look at our answers here, there is not an encryption mode within IPsec. That's not a specific mode. It does encryption, of course, but there's not an encryption mode. Tunnel mode was, in this particular case, the correct answer of which IPsec mode encrypts your data, IP address and data during transport. It's not transport mode, although that is the other mode we're talking about, you 6% of you. There is no authentication mode. There is no secure mode. I made those up too. So kind of a trick question. I made things up. You will possibly get questions on your CompTIA exam that does ask you some of these things, and they do mix it up a bit. They may give you answers that have nothing to do with anything. All right, more questions. No answering in the chat room again. The questions I have for you, this one is, which of these technologies is used in large environments to maintain the uptime and availability of a service? Indeed. What does use that particular thing? Well, let's find out. We've got some options available. If you've ever worked in the enterprise, you've probably seen these types of devices before. Maintaining uptime and availability of a service. Is that a caching engine? Is it an SSL accelerator? Is it a solid state drive? Is it a load balancer? All of these things can be used in a data center. All of them may have some type of functionality with the way applications work, but only one of these is really going to maintain uptime and availability of a service. And that is one of the things that you will absolutely run into when you start getting into I say very large environments, could be even very small environments, you need to be able to keep uptime and availability there. The email always has to be running. The database always needs to be available. The website always needs to be up and available as well. There's ways that you can make sure that those resources are always going to be available for everyone. So you want to choose between caching engine, SSL accelerator, solid state drive, or load balancer. And you can, of course, go to the Socrative website to be able to see the possible answers there. Well, let's see how we did on this one. I think again, I may not have fooled very many people with this one, because a lot of you realize, yes, that's a load balancer. Some of you, I think, have been working very hard on your CompTIA Network Plus details. That's the load balancer. In fact, if you've gone to the Professor Messer website, you have used a load balancer. If you're watching this live on the Professor Messer website, you chose one server to go to based on a load balancer that everybody hits. So it's one of the very first things once you really get past I've got multiple redundancies built in. I've got a reverse proxy that you may be hitting. You may be hitting a different reverse proxy depending on where you are in the world. That reverse proxy is hitting a load balancer that's then going to a number of web servers to be able to select this. That way, if I do have a web server that crashes for some reason or another, everything will now go to the secondary server and everything will remain up and running. And that's what I want to do, is make sure that all of my services are available all the time. This is when I start getting into these things that I really, really want to be able to work and keep things up and running all the time. And that's why when I look at these other options, there's performance functionality there, but not necessarily redundancy there. Let's talk a little bit about that, because load balancers can be really, really useful. I've got those multiple servers in my world, and I put in here it's common in large environments, but I have a website. I have multiple web servers. I have a database server on the back end that everybody's going to. There are also protocols that are used with these load balancers so that the load balancers can talk to each other and so that your load balancer can talk to the other devices. Because how would a load balancer know that a device is active or not? So it uses a number of different protocols. There's also one you can run on a single server that has multiple network interface cards inside of it, called the Common Address Redundancy Protocols. And you can set up multiple boxes. They all have the same IP address. How you like that one? That's something you don't normally do, but they use this redundancy protocol to keep everything straight. Obviously, this requires a bit of engineering to get running. I use an external load balancer in my environment. That's its only job is to load balance. I don't have to modify anything with IP addresses. I don't have to change anything on my servers. I don't have to load additional software. I don't have to run special protocols. This load balancer is simply checking in and performing a simple test every second to my server, effectively asking, "Are you still okay?" "Yes, I'm still okay." "All right, I'll find out more from you in a second." "Okay, how about now?" "Yep, I'm still okay." "How about now?" "I'm still okay." So it's constantly doing that in the back end. And if suddenly a server doesn't answer, it now decides I'm going to send all my traffic to the one that is up and running. That's one of those things that when I start working in these environments and dealing with load balancers, I am really glad that I've got that load balancer there. And in fact, there will be some rebootings of my server, some maintenance of my servers this weekend that the provider is doing. I don't have to worry about it because I've got my load balancer there to be able to do that. So I think that part's great too, have that piece there. All of these things you'll need to know for your Network Plus certification. So just keep in mind that you've got all these servers. This is almost exactly the scenario I have for the Professor Messer website, where it's the separate load balancer to be able to do that. So congratulations, the 81% of you that answered load balancer, you were absolutely correct. Let's go to another question. Now let's really get into the networking piece of it. We've done enough security. We've done enough application stuff. Let's get into the deep part of networking, and that is some wires. Everybody likes wires. And the question I have for you is, which of these would be the best choice for finding the two ends of a network drop that extend from a desk to a 110 block in the IDF? Now, who hasn't tried to find the end of a cable? I was trying to do that just before the study group happened. So you can use a particular device, a particular tool to be able to do that. Let's see what our options are for that piece. We have an option of a toner probe. We have a punch down tool. We have a loop back plug, and we have an OTDR. So all of these things can be used when you're working with wire, but I'm looking for the best choice to be able to find the two ends of a network drop that go from a desk and probably into the ceiling or under the floor. Who knows where this cable is going? It eventually, we know, ends up somewhere in the IDF on a 110 block. How do we find the two ends? Go. So that's one of those things that you will be doing as a network professional, is hunting down the ends of cables, because you need to move it, you need to change it, you need to modify what's there. And it's hard sometimes if things aren't well documented to know exactly where the two ends of that cable happen to be. So we've got some options there. Make sure you go out to Socrative.com to be able to answer that particular question. This is where we're really looking at how we are doing with this. I have a suspicion that some of you have used this technology before. And the reason I say that's because I'm looking at the answers that are coming in. And in this case, I'm not really fooling very many people at all. I think a lot of you are ready for your Network Plus certification. You're answering these very, very well. The answers so far, we've got I'm waiting for 2 or 3 more people to answer. There we go. So we've got 76% of you said toner probe. And in this particular case, kind of hard to hide it. That one would be absolutely correct. Nobody said punch down tool. I don't know why. I threw in the 110 block thinking you would absolutely say punch down because it says 110 block in the question. I didn't fool anybody. It's not a loop back plug. I don't know where the end of the cable is, so it's kind of hard to loop anything back. And it's not an OTDR, although OTDRs do, or they may have some functionality in them to be able to send a tone down a wire. They don't usually do it. That would be a very much overkill. And in this particular case, I was saying a wire, not a fiber. An OTDR is an optical device. It's using fiber to the time domain reflectometer. That is a device that's really used to look at the quality of the cable, and you really need to know both ends and where they are to be able to use the OTDR or the TDR if you're using wire, copper wire. So in this case, a toner probe would be the correct answer. We see these toner probes all the time. This is what they look like. They are really inductive devices. You don't have to physically touch the copper to be able to use these. This device that we see here is a tone generator, and it plugs into the wires. If you just have one end of the connection, they usually have RJ45 connectors on them. They have RJ11 connectors on them. They have alligator clips on them. You never know where you're going to be connecting in. So they've got a lot of different ways to connect into the copper wire. So you plug in the tone generator and you turn it on, and it sends a tone, a signal through that, just an analog signal through that particular set of wires. In fact, this tone generator gives you the option of turning on a dual tone or a single tone. Most tone generators will do dual tones. It goes da-da-da-da-da-da-da-da. It just makes this annoying noise, but you can't hear it unless you have something to listen. And this inductive probe has a little speaker on the end of it, and you need to now get near the wire. So you know it's on this big 110 block somewhere. And the tone generator is sending the tone. So you go to your desk where you know the end is, you plug in your tone generator, you walk back to the IDF, and you start using the inductive probe. You're listening through the speaker there, and you're going through all the wires. It's completely quiet. And as you get closer and closer to where that wire is, the tone gets louder and louder. And ultimately, when you touch this plastic end of the inductive probe onto the wire, it's going to be the strongest it can possibly be. So that makes it easy. You don't have to break any cables. You don't have to get down to the copper. It's able to pick up that signal through that plastic sheeting that's around that and insulating that's around that particular wire. Very, very useful to have there. So make sure that you use those. Yeah, this is nice. The tone generator only has to be on one end, and it's going to send the tone through. So now you're the one who has to now find the other end, and it's that inductive probe that's going to allow you to do that. Very, very useful to have that capability there with that tone generator. And you folks did pretty well with that one. We did 74% of you said toner probe. You'd be absolutely correct with that. It's one of those where if you need to find the end of a cable, if you've seen some of these huge walls of 110 blocks, how in the world are you going to be able to find that? And it is so easy to be able to do that with the tone generator, because you just simply go along the list of all the wires, just barely getting near them, and you can start to hear that particular noise coming through. Very, very simple to be able to do that. Well, I want to take a moment and thank the folks at GTS Learning for helping us out with this study group. This is something, as I mentioned, that we do every month, and they are nice enough to help support what we do at Professor Messer. It's very nice also because I use the GTS Learning materials. They have books and training materials. I use their materials to build my courses. So this is great. They allow me to take everything that they do and even take images and graphics from their books and make them available to you for absolutely free. But they also have a few things that I think you might be interested in for the Network Plus certification course. Now, as you probably know, there are these performance-based questions that you have to know on the certifications. And these performance-based questions can really ask you quite a number of different things. The performance-based questions that I've seen, they could be multiple choice. They could be fill in the blank. You might have to perform a function at a command line. Certainly for the Network Plus, that might be valid because you may be going through and working with the traceroute command or the ping command. And what GTS Learning has is a series of labs that are already set up and ready to go for Network Plus. And everything is there that you would ever need to do. The devices are already configured. They've already got the network connections set up. They already have the machines configured for the labs. The labs are already written. They have everything, and they do it all in a virtual environment. You don't need any software in your computer. You don't need to load anything special. It's all done through their front end. In fact, I've got their labs running right here on my screen. I just started these up. I've got all these devices over here on the left side of the screen for my server, my client, my gateway, my router, and a machine that's running LAMP, which is our web server in most cases in most of these labs. And I powered them on. You can see the gateway just turned green. So he's now running. He's up and running. And I'm waiting for my server and client. They have a lab here that you could step through sections 1 through 6. First, they tell you what the network is set up with the server, the gateway, the LAMP server, the client device, the router that's in the middle. You have all the IP addressing, and you can pop this out or even download it as a PDF and have it on your other screen. I have it all crammed here so you can see all of it. Here's the first exercise. They even give you screenshots to take you right through the exercise to be able to do this. And they've all got Windows running on here. You've got Linux devices running on here. They've got many operating systems, so you don't have to have any extra hardware. You don't have to load any virtual machines on your machine. If you want to go to a Windows server, you click the Windows server, and it's going to give you a web front end that you can now do things like run Wireshark. So I'm running Wireshark now and capturing packets on this network, except I didn't specify an interface. Here we go. I'm capturing packets on this network out here, and I don't have any equipment here. There's my packets I'm capturing. The response time's great on here. It's all a remote desktop effectively to be able to see these things. And I've got a client that just started up. I'll connect to the client at the same time. So I'm running my server and my client at the same time. And I can run Nmap here. I've got gateways and Linux machines. It's all here. And you can step through the labs and get a better understanding of how all of these things work together. I can capture the traffic. I can step through and understand a lot about where the Network Plus certification really requires. I've also got a special price from GTS Learning. If you go to their website, it costs you $159 to have access to this for a year, but they've given us a special price. And if you go to professormesser.com/netlabs, you will also be able to take advantage of this special price, $99, and you'll be able to use this for a year. Load it up and run it as much as you want across all of the labs that they have. It's a really nice value. And if you're someone who doesn't want to set any of this up by yourself, you don't want to be an operating system expert, you want to be a networking expert, this is a great way to do it using the GTS Learning Labs. And I want to thank GTS Learning also for allowing us to take advantage and use their materials to build these courses out and to give us the special pricing for those of you that are using these as well. Well, there is very, very useful to be able to run through and use these capabilities. I also have, of course, questions that I like to ask you. So let's get back to some of the questions that I have for you. I've got another one here. Here it is. Which networking technology, and really technology, I'm only looking for one of them in this list, so I'll have to fix that. We'll fix that in post. We won't fix that in post. Uses different colors of light to transmit multiple carriers. There's only one I'm looking for from this particular list. And if you look at the list, you've got some options available to you. And again, it's a as many things are in networking, just a bunch of letters thrown together. So which networking technology uses different colors of light to transmit multiple carriers? Is it DWDM? Is it ISDN? Is it PON, PON? Is it WiMAX? Is it MPLS? One of these, I'm only looking for one, uses different colors of light to transmit multiple carriers. Very interesting technology to be able to do that. I think that's one of the things that that I like to have is plenty of bandwidth. And if you've ever looked through a fiber connection, a traditional fiber connection, it's using one bandwidth of light, one frequency of light, better way to say it. And it's only one color of light. There's a particular technology, though, that's going to use multiple colors. So it's going to be one of these. It's going to be the DWDM. It's going to be the ISDN. It's going to be the PON. It's going to be the WiMAX. It's going to be the MPLS. You go to Socrative.com and you can answer this question as well. Socrative is going to tell you and walk you through all of those. So finally, I have hit one where we just aren't quite exactly sure which one of these might be. We're getting quite a mix back and forth over what we're going to do here. Is it going to be this one? Is it going to be that? Some of you are changing your answers, which you can do in Socrative. We're not grading this. You won't get a grade at the end. You'll get the certification for watching just by being here. So don't worry too much about that one. This is a relatively new technology. You want to think about it. Using different colors across a single fiber would certainly give you a lot more capabilities, a lot more bandwidth, a lot more traffic that you could put through, because each one of them would effectively be its own little channel. And as we say in the question, not just its own channel, but its own carrier. That's the thing that we create, that we stick all of our data through. So multiple carriers there. We're effectively building different pipes on the same piece of fiber. And as you can imagine, that can really extend the functionality, especially in places where you just don't have a lot of fiber to work with. Very, very useful. So let's see what the different options might be and how you answered. 36% of you said DWDM, 5% of you said ISDN, 15% of you said PON, 13% said WiMAX, and 31% said MPLS. Well, in this particular example, if you wanted to really look at which one of these would be the best answer for this, it would be DWDM. DWDM stands for dense wavelength division multiplexing. It's the dense wavelength that we're really talking about here, having those different frequencies of light that we're sending through. So we've got a single fiber. We can now put a lot of information through there, effectively give us more bandwidth in the same fiber. We didn't have to add any more infrastructure to be able to do that. This is using effectively those different colors to send it through. Pretty nice to have that there. So you could take a 10 gig system that you currently have, and the idea is if you've got the right fiber in the ground, you can change out the equipment on the ends to stick the DWDM equipment on both ends and add 160 separate signals to this fiber, expanding it to 1.6 terabytes per second. So that is a pretty impressive increase in bandwidth. You generally don't see these in enterprises or in places where there is a smaller amount of networking. Usually it's the carriers, and I mean the telephone company carriers that are using this equipment because they want to maximize how much data they can put through these fibers. Especially if we're talking about going under the water. That's a very expensive thing to put additional cable or fiber underneath the water, or even across areas that's very difficult to do any type of construction. So it'd be great to use DWDM to make that happen. And for those of you that answered on this one, we've got quite a few answers that came through on this one. DWDM is definitely the A answer that you have there. 33% of you would be absolutely right with that one. So it's another example of how you can take these topics that the Network Plus gives you, and they may step you through a number of them. So let's look through this really quick. ISDN is the Integrated Services Digital Network. That is one you don't see much anymore. Really, broadcasters use it these days, and people doing voice work from home because you get such a nice signal. But you don't generally see ISDN being run any longer. That's using old copper connections, your old phone lines to be able to do that. PON is a type of newer system of communicating, but it's really a passive system that's using optics and really mirrors to be able to send this traffic back and forth. I like having the capabilities there of knowing about DWDM and knowing about PON, because the carriers are using those. The big companies providing the telecommunications links are using those. So it's important to know what those pieces are as well. WiMAX is a wireless technology, so we're not really dealing with light there. And finally, MPLS is a type of networking really at layer 2. So we're not even talking about fiber or copper at that point. We're really talking a little bit higher up the OSI stack. So that would not be the answer either. Let's get a sip there and see if we can step through to another question then. So don't worry if you didn't happen to get that one. I've got more wiring questions for you. So let's do a wiring question. What distance is supported with the 1000 base T standard over category 6 cable? We should be able to get some type of options from that. If you're doing any type of cabling, you're certainly going to need to know how far this can go. And so that's what this question is all about, is knowing how far I can string this cable. We were having a discussion about this in the chat room this week, which is why I added this question. So how far can I go with a 1000 base T standard cable over Cat 6? Can I go 55 meters? Can I go 100 meters? Can I go 2 kilometers? Can I go 10 kilometers? How far can I go? So yeah, again, you have to know these multiple steps. I have to know what the 1000 base T standard is, and then I have to know how far I can extend it. This is one of those that seems like a rote memorization question. It seems like it's one of those that I just need to know it because I need to know it, but actually these are things that you definitely need to understand. And it's because in the chat room this week, we were talking about how far can we really run one of these connections. And we were talking about the capability that you could even extend it farther beyond what the standard says and still have a successful, at least somewhat successful connection to the other side. And as we were going through that, we were really discussing, is that a right thing to do? Is it a good thing to do? It probably isn't a good thing to do. In this scenario, the person didn't have a choice. They had to extend it beyond the capabilities. So we were talking about different options. Well, you could string up the cable and see if it makes it. You know, just because the standard says that's the maximum doesn't mean that physics won't actually allow it to happen. So there's some options there to be able to do that. And you also have to look at the standard itself and what the options might be for that as well. If we look and see how you folks have looked at the standard to see what it is, again, we're all over the place with that one. So we've got 3% of you said 55 meters. 68% of you said 100 meters. If I had to go with what the popular vote is, we'd go with the B. But 15% of you said 2 kilometers and 15% of you said 10 kilometers. So what would it be if we were going to look at these? Well, of course, if you go to my CompTIA Network Plus course, you know that I have this all written up for you. And so the question here was about 1000 base T. Now, anything that ends in the T or the TX is going to be copper. So it's not going to be a fiber connection. We're not going to be able to figure out if we can extend it based on the type of fiber that we're going to use. Nope, this is 1000 base T, and we're talking about category 6 cable. One of the nice things about these standards is they really limited everything to about 100 meters. The only example is perhaps 10 gig over category 6. In the standard is limited to 55 meters unless you have the newer category 6A cabling. Everything else, 100 meters. It's 100 meters, it's 100 meters, it's 100 meters, it's 100 meters, it's 55, it's 100 meters. So it's pretty much 100 meters across the board. So the 70% of you or so that said, yeah, 100 meters, you would have gotten that one absolutely correct. And if you are watching this to get your CEUs, you want to get an email from me that certifies that you did indeed watch this particular study group, you should send me an email by going to the Professor Messer website. And at the top of the screen is a Contact Us link. And follow that Contact Us link and fill it in and send me just a message. All it has to say in it is 100 meters. And as long as you have that particular key phrase in there, I will send you an email back that certifies that you did indeed watch this and you deserve at least that 1 credit for spending the time with us and going through that today. But first, I have another question for you. Which OSI layer is most associated with an IP address? The the OSI layer, probably the most requested topic. And it's interesting, it's such a small part of the exam, but because it is the first foray into networking and you're really trying to understand this from the top down, the OSI model is not a real thing. You can't put your hands on it. It even has a bit of changes. If you go from one person to another, you actually might get a different answer. So sometimes it's even hard to narrow down exactly what we're talking about. But in this particular case, with this particular question, there is no doubt what this particular OSI layer is. We can always fight about that later. And to make things even more complicated for you, I'm not giving you an out. I'm asking you very specifically, which layer is it? And the layers are 1, 2, 3, 4, 5, 6, or 7. So you don't even have a choice here. I'm giving you all 7 layers of the OSI model that you have to choose which one is most associated with an IP address. This will help you because when you are working with switches, when you're working with routers, when you're working with applications, when you're working with trying to get your carrier up and running over your DWDM network that you just bought for a whole lot of money, you may run into problems with IP addresses. And somebody may refer to you, oh, you're running into an OSI layer X problem. And you're going to need to understand, what in the world are they talking about? Layer what? The layer, huh? I'm not even sure what they mean. So you need to also figure out and know in your minds what these are, because we just happen to use them in the normal communication that we have with going back and forth over these. Now, one of the advantages we have with these types of scenarios in the OSI model is we've started to call our devices with these particular names. So IP addresses especially, very, very useful to be able to do that. So in this particular case, I think some of you have heard of those particular devices. A layer 1 device is more the physical layer, the signal going across the copper or the light going across the fiber. Layer 2 is more of the MAC address, the data link control address, the DTE, DCE address, if we're talking about a wide area network. Layer 3 is your IP address. If I have a layer 3 switch, what that really is a switch that also has routing functionality built into it. So I have both a switch and a router. It's not just a layer 3 switch, it's a router switch. That's what it is. Or if you're talking about a router or installing a firewall, we're going to install this firewall in layer 3 mode. And what that means is each connection into the firewall will get an IP address, and we will route between those IP addresses. That's what a layer 3 is. Layer 4, we're talking about port numbers. So we're getting outside the scope now of IP addresses. We're talking about TCP and UDP and the different port numbers they use. And 5, 6, and 7, we're really talking about application level views of the world. So if you're one of those people that answered, the 74% said layer 3, you would be absolutely correct. If we wanted to take the OSI model and really break it down into the different pieces, we could go through and kind of categorize these different things at different layers. And I think that's where you get into the challenges of understanding the different layers, is that it's hard to map them back completely to real world pieces. And this is, I think, is a pretty good diagram that at least goes through a number of the real world pieces of, well, there's your eyes and there's a TCP segment and there's a cable. And you can at least go to that particular OSI model to understand more about it. I think that's where we really get into understanding those pieces and getting a feel for those. So let's, and by the way, we'll go back to this. We got the layer 3, 75% of you said layer 3, you would have been absolutely correct. The idea of cabling, especially these OSI layers, comes into play when we start working with VLANs. And so the question I have for you is more of that layer 2. We started in security. We're coming all the way back down through the wiring and down into these different OSI layers. What is a group of VLANs that share the same wire? This is something that when you start working with switches and configuring switches and trying to get them running, you need to know the answers to these. And we have a number of options available to you. I put a lot of things in here. So what is a group of VLANs that share the same wire? Is it link aggregation? Is it a trunk? Is it encapsulation? Is it line rate? Or is it a port group? One of these is going to be correct. A group of VLANs that share the same wire. If you have a switch in practically any environment, you're going to be configuring VLANs. And even in my little tiny studio that I have here, I've got multiple VLANs set up. Even here, it's just one person. It's me. There's not even multiple people, and I've got multiple VLANs running in this scenario. I guess if you look at that picture, you can see why there's multiple VLANs in my particular environment. I've got a little bit going on here. So you need to answer this question too for yourself. Is it link aggregation? Is it trunk? Is it encapsulation? You can go to Socrative.com to answer all of those things. You could probably see it better if I do that. Got a lot happening there. There we go. Get the right thing on the screen for you. So how do we do with that since we went through these pieces? Well, we're sort of all over the place here, although we do have a clear majority. 68% of you said trunk, but 11% of you said link aggregation. 11% of you said encapsulation. None of you said line rate. And the one that I threw in just to see if I could get anybody to bite on it was port group, and none of you said port group either. 69% said trunk. And that is really the best way to describe this, because that's when we talk about putting multiple VLANs through a link, we are talking about a trunk that we would put through the link. In a very simplistic way to view this, we have, let's say, these different departments. We got a red department, a green department, and a blue department. Maybe that's marketing, that's engineering, and that's shipping and receiving. And it used to be that everybody would be in their own little area of a building. And so we could connect everybody in that little area to their own switch or their own router, and we could provide security. We could give them local access to their printers. We could give them better access to the resources they needed. But of course, it doesn't work that way, really. In reality, you got people everywhere. They are all over the place. They're in different buildings. They're in different cities, but we still need to keep things together and get these people. So they're mixed up. There's people, the green and reds are together in one building. The blues and reds are on a different floor. The greens and blues are on a different floor. So one of the things you can do is you can connect your switches up using what we call trunks, where we are connecting up all the greens to each other, all the blues to each other, and all the reds to each other by creating these virtual local area networks and sending them all through a single wire. Very nice to have that functionality. You've got now the capability to keep everybody separated and in their own little specific area, but do it all over a single wire, which means you don't have to run any additional cable. You don't have to administer additional ports on a switch. You're sending everybody down usually a higher speed link. We'll usually put a gig or 10 gig links between these switches and devices, and maybe 1 gig down to the users. So we're still able to maintain availability. We got plenty of bandwidth for everybody to ride over that road. We're simply building the road out with separate lanes so that everybody can get from point A to point B. Very, very useful to be able to do that. Let's do another question dealing with protocols. So by the way, let's see how we did with that one. And again, 77% of you said trunk. I really didn't fool anyone with that one. Well, let's see, now that we're moving up that OSI stack, let's see how well we do with routing protocols, shall we? The question I have for you is, which of these is an EGP? Well, I've got a list of EGPs here. I want to know which one of these is an EGP. Your questions, your possible answers are OSPF, BGP, RIP, EIGRP, or static. So one of these is an EGP, whatever that is. And again, that's why I write them this way, so that you can first have to understand what an EGP is, and then you have to know what all those other things are, so that you can then put that into context of what an EGP might be. And this is one where you're really getting into the routing side of things. Fortunately, the Network Plus doesn't dive too far into the intricacies of these particular routing protocols. The EGP is something, and we're dealing with OSPF and RIP. You may have seen immediately, that's a routing protocol. I got that part. So one of these routing protocols is an EGP. That, fortunately, you don't have to know exactly how all of these work. There are other certifications where they will certainly take you down that road, where you can start learning more about the way those work. But I think this is a good one to go through and try to figure out those pieces of it. So, well, and you could see if we look at interior gateway protocols, I'm asking you about EGP in this one, but I'm also starting the conversation here with IGPs. And you can see IGPs are used effectively, they're interior protocols. They're used inside of what we call autonomous systems, but generally inside your organization. So some IGPs would be OSPF, ISIS. You've got, what else have we got here? I'll click some buttons. RIP. You've got also RIP version 2, because there's multiple versions of RIP, EIGRP, and these are things that you'll see in practically anybody's environment on the inside. So if those are interior gateway protocols, you notice my question asked you about an exterior gateway protocol. Well, let's see what exterior gateway protocols there could be. These are generally used between your organization and some other organization that's not part of you. It is an exterior protocol that you're using on the outside. You're connecting between what we call autonomous systems, or ASs. And the one that you'll need to know, and generally the one that is used the most as this exterior protocol, is BGP. If we wanted to put these all on a screen and see how this works, you can see you've got one company A here. They're using RIP. Company C is using EIGRP on the inside of their company. Company B is using OSPF on the inside of their company. Company D is using RIP v2. But if all of these want to talk to each other, perhaps on this thing we call the internet, you would use the exterior gateway protocol, BGP. And I'm glad I could end my study group with you folks all over the place with OSPF, with RIP, with EIGRP, with static routes. Nope, the exterior gateway protocol would be selection B, which would be BGP. So if you chose BGP, you would be absolutely correct. There is a lot to the Network Plus exam, and I have to recommend anybody, if you're going to be taking your Network Plus exam, get the objectives. Go to professormesser.com/objectives, or just type in CompTIA exam objectives Network Plus. It will take you right to the page in that Google thing that's out there. That's something you cannot do without. You must download these objectives. You must read through them. They are a fantastic master resource for you. They're a huge list that you can then check off. Do I know that one? Yes. My master list, I can just check off everything there. That's my big master checklist. Make sure that you have that particular checklist there. I have one last question for you. This one, you don't have to get right or wrong. This one is really something that says, if you like what's here, you can absolutely give me feedback about what you would like to cover on the next Network Plus study group. And this gives me some ideas of questions that I will ask you next time. And I get these also from emails you send me, from Facebook messages, from Twitter messages that pop up, from things we talk about in the chat room, which is going 24 hours a day, 7 days a week on the Professor Messer website. Very, very useful to have that there. Go to Socrative and you can answer what you would like to cover on the next Network Plus study group. I'm going to leave that up after this is over. So if you're watching this on the replay and you think I would like to put something in there, go through. You can absolutely connect to Socrative. That will be the one question that will be up on Socrative that you'll be able to answer on those particular pieces. Well, that covers everything in the formal study group that we have. Stick around for the after show. But if you'd like to look at the capabilities of our study guide, I have a page you can look at professormesser.com/netsg. And of course, you can follow all the new videos I put on YouTube at professormesser.com/YouTube. professormesser.com/Twitter gives you some Twitter things that I do from time to time, /Google+, /Facebook. That's the way you can use to get back to me and send me information and see what's going on here. And I got to tell you, there's a lot that is going on here. Those particular things will be blowing up over the next month, I suspect. I also want to thank my friends at GTS Learning for giving us not only the material to build these courses with, but they also have these great prices for us. If you'd like to learn more about their freestyle training, you can, of course, find it at professormesser.com/netlabs to be able to see more about that. And of course, I didn't mention this, but if you decide to get their Net Labs, you also get that book for free online. You'll be able to look at the entire book. I think they also have some questions, some Q&A that you can do. And of course, thanks to you, we would not be able to do this study group if you weren't here and giving us the questions and telling me exactly what should be going on there. So I want to thank all of you for that. If you're watching this live, stick around for the after show. Otherwise, we'll see you next month on the Network Plus study group. Thanks, everyone.